Hello friends, welcome to QLS Academy. I am your chemistry faculty and today we are going to learn about constituents of matter. We are going to learn about atoms and molecules. Hope you will enjoy today's class. So let's get started. In last chapter we saw that matter is made up of tiny particles. These tiny particles are called atoms. But the existence of atom was not proved until late 18th century. But the idea of existence of atom had been there in the ancient world. Around 500 BC, an Indian philosopher Maharishi Kannan and Greek philosophers Democritus and Leucippus postulated that if we keep on dividing matter, we will get smaller and smaller particles, and ultimately a stage will arrive when the particles will become indivisible. Maharishi Kannan named this indivisible particle as Parmanu, while Greek philosophers named it as atom, means indivisible. Another Indian philosopher, Pakuda Katyayama, predicted that these indivisible particles usually exist in a combined state. Means ये freely exist नहीं करते हैं, ये किसी न किसी और particle के साथ combined रहते हैं. By 18th century, scientists proved that these philosophies were right, that matter is indeed made up of atoms. Atoms are the building blocks of any matter. जैसे बायोलॉजी में सेल्स किसी भी ऑर्गेनिज्म के बिल्डिंग ब्लॉक होते हैं, उसी तरह केमिस्ट्री में एटम्स किसी भी मैटर के बिल्डिंग ब्लॉक होते हैं. दे आर लाइक ब्रिक्स ऑफ अ हाउस. जनरली द रेडियस ऑफ एटम्स आर 10⁻⁻10 मीटर. एटम्स आर indivisible and also atoms exist in a combined state called molecule. जब दो या दो से ज़्यादा एटम्स कंबाइन होते हैं, they form a molecule. Sometime later, Anton Lavoisier and Joseph L. Proust, from their experimental observation, established laws of chemical combination. The first law of chemical combination is the law of conservation of mass. This law states that mass can neither be created nor be destroyed in a chemical reaction. The total mass of the reactants is always equal to the total mass of the products, irrespective of the physical and the chemical changes that occurred during the reaction. The second law. The second law is the law of constant proportions. This law states that chemical compounds always have a same definite proportion of elements from which it is formed. The second law was put forward by Louis Proust, hence the second law of chemical combination is also known as Proust law. लॉज ऑफ केमिकल कॉम्बिनेशन के आने के बाद भी एटम्स का कोई एक्सपेरिमेंटल प्रूफ नहीं था. देयर वॉज नो अप्रोप्रिएट एक्सप्लेनेशन फॉर द लॉज एज वेल. सो बेस्ड ऑन द लॉज ऑफ कॉम्बिनेशन, अ ब्रिटिश केमिस्ट Sir John Dalton put forward atomic theory, which we today known as Dalton's atomic theory. Dalton postulated 6 postulates. First, matter is made up of tiny particles called atom. Second, atoms are indivisible and they can't neither be created nor be destroyed in a chemical reaction. Third postulate, atoms of a given element are identical in mass and other chemical properties. Fourth postulate, atoms of different elements have different masses and chemical properties. Fifth, atoms combine in a ratio of small whole numbers to form compounds. Sixth, the relative number and type of atoms are constant in a given compound. Means water H2O हमेशा 2 hydrogen atom and 1 oxygen atom से ही बनेगा. The number of hydrogen atom and oxygen atom won't vary. If the number of oxygen atom increases by 1, it will become H2O2, which is hydrogen peroxide, an oxidizing agent. We can't drink H2O2 as we drink H2O. Dalton also proposed some symbols to represent elements, like the symbols you can see in this image. The single letter or 2-letter symbols which we use today were suggested by Berzelius. Nowadays, IUPAC, International Union of Pure and Applied Chemistry, governs the system for naming of elements and chemicals. Elements are symbolized either by using the letters appearing in their English name or by using letters from their Latin, Greek or German name. The first alphabet of every symbol is usually written in uppercase. If a second alphabet is also used, it is usually written in lowercase. For example, symbol of hydrogen is H, symbol of carbon is C, symbol of oxygen is O. While the symbol for helium is He, H capital, E small. Similarly, silicon is represented as Si. Some elements are symbolized by using their first alphabet and the alphabet occurring later in their spelling. Like chlorine is Cl, magnesium is Mg, zinc is Zn. Elements like iron, sodium and potassium have got their name and symbols from their Latin names. Iron is ferrum in Latin, hence its symbol is Fe. Sodium is natrium, hence its symbol is Na. Potassium is kalium with symbol K. Silver is argentum with symbol Ag. And copper is Cu because its name is cuprum. Now let's talk about the mass of the atoms. Atoms are so tiny that we can't see them even under a compound microscope. So, how can we measure the mass of such a small particle? The mass of atoms were determined using the laws of chemical combination and the new compounds that formed during the chemical reaction. Finding the exact atomic mass of an atom is not possible. Therefore, atomic mass of any atom is determined relative to mass of carbon-12 isotope. By experiments, it has been determined that 1/12 atomic mass of carbon-12 is exact 1. Carbon-12 का mass होता है 12. So, इसका 1/12 mass होगा कितना? 1. So, that's why carbon-12 is selected to determine the atomic mass of atoms of other elements. Atomic mass is sometimes also denoted as relative atomic mass, as it is relative to carbon-12. So, atomic mass of an atom of an element is the number of times that atom is heavier than 1/12 of the mass of carbon-12. Initially, atomic mass unit was denoted as AMU, atomic mass unit, but later IUPAC revised it to U, which is unified mass. Now, let's step up. You remember that philosopher Pakuda Katayama and Sir John Dalton predicted atoms exist in a combined state. Atoms do not exist in a free state. Atoms freely exist नहीं करते हैं. The combined state of atoms is known as molecule, or we can say that atoms combine to form molecule. Atoms bind to each other through chemical bonds to form molecule. A molecule is the smallest particle of any element or compound that can exist independently. For example, H2O molecule of water, Cl2 molecule of chlorine, O2 molecule of oxygen. H2O, Cl2, O2 molecules are formed by two atoms of their respective elements. But it is not always necessary that two atoms combine to form a molecule. हमेशा दो atoms के combination को ही हम molecule नहीं कहते हैं. Combination of 3, 4, 5, 6 or even more atoms is also called as molecule. The number of atoms constituting a molecule is called as atomicity. A molecule formed of two atoms is said to be diatomic, like O2, Cl2, H2. A molecule formed by combining three atoms is known as triatomic, like O3, ozone, and sulfur, S3. A molecule formed by four atoms is tetraatomic, like P4, phosphorus. A molecule containing many atoms is called polyatomic, like S8, sulfur, with 8 atoms combined. There are also some elements whose molecule are formed by one single atom. अभी हमने देखा कि atoms combine होकर molecule बनाते हैं, but कभी-कभी ऐसा होता है कि एक single atom को भी हम molecule कह देते हैं. Such molecules are called as monoatomic, since only one atom is involved in its formation. Helium, neon, sodium, iron, copper are some examples of monoatomic molecules. Remember the fifth postulate of Dalton? Atoms combine in a ratio of small whole numbers to form compounds. Molecules can be of two types, homoatomic and heteroatomic. Homoatomic molecules में same type के atoms combine होते हैं to form a molecule of an element. Homoatomic molecules means element के molecules. But जब different type के atoms combine होते हैं, they form a compound, a heteroatomic molecule. So, a molecule of a compound is always formed of atoms of different elements. The proportion of atoms to form molecule of a compound is constant. For example, CO2, carbon dioxide. Carbon dioxide form होने के लिए हमेशा एक कार्बन और दो ऑक्सीजन एटम्स ही कंबाइन होंगे. So the simple ratio by the number of atoms of elements to form CO2 is 1:2. Mass ratio निकालने के लिए हम क्या करेंगे? We will first find out the total mass of each element. हर एक एटम का मास होता है अपना, हर एक एलिमेंट का एक स्पेसिफिक मास होता है. तो हम सबसे पहले किसी एलिमेंट का मास फाइंड आउट करते हैं. लाइक CO2 में एक कार्बन है. एटॉमिक मास ऑफ कार्बन इज 12U. So the mass of carbon in CO2 is 12U. Similarly, atomic mass of oxygen is 16U. और यहाँ हमारे पास ऑक्सीजन के 2 एटम्स हैं. So the total mass of oxygen in carbon dioxide CO2 will be 16 multiplied by 2, which is 32U. Now to find out the ratio of carbon and oxygen, we will divide the total mass of carbon to the total mass of oxygen, which will give out 3:8. So the mass ratio of carbon and oxygen to form CO2 is 3:8. The compounds are not only formed by simple atoms, they are also formed by ions. Metals and non-metals के combination से जो compound बनते हैं, they contain charged particles. For example, NaCl, sodium chloride, calcium oxide, CO, magnesium sulfide, MgS, and those charged particles are known as ions. A positively charged particle in a molecule is called as cation. For example, Na+, Ca2+. Cations are generally formed by metals. Metals जो हैं वो cation form करते हैं हमेशा. The negatively charged particles in a molecule is called as anion. For example, Cl-, F-. Anions are usually formed by non-metals. Charge सिर्फ charged particles पे होता है, ions पे होता है. नेट चार्ज ऑफ द कंपाउंड, पूरा जो कंपाउंड है उसका जो नेट चार्ज होता है, टोटल चार्ज होता है, दैट इज ऑलवेज 0. द रेशियो ऑफ एटम्स टू फॉर्म आयनिक कंपाउंड्स आर आल्सो ऑलवेज कांस्टेंट एंड कैन बी डिटरमाइंड just the way we determine the simple ratios of normal compounds. So, what did we learn today? Today, we learned about atoms and its properties, how atoms combine to form compounds, and we also learned something about charged particles, means ions. In next class, we'll learn about writing chemical formula. If you have any doubt or need any further information, you can visit the following link.